So let's start 5.4. 5.4 is different because we're going to look at sample data. And so what would happen is we have what's called the central limit theorem. If we let the sample size get bigger and bigger, remember we talked about sample size. So we have a population, which would be everyone if we were able to talk to every single person that we needed or be able to look at every single data point we needed to look at. But that's not realistic. So then we go to looking at samples. Well, if the sample gets, as the size gets bigger and bigger, then the data will start to look like a normal curve. So if you look here at the blue, that would be, whoops, I'm in the wrong thing here. If you look at this blue curve, that doesn't look exactly normal, right? It looks a little bit skewed to the right. And that's because we just don't have enough data points that we've looked at. But if as the sample size gets bigger and bigger, it's going to get closer to the red graph, which is our normal bell curve. All right, so again, things that we are not going to memorize, we're just going to get used to of whether we're working with the population or we're working with the sample. So in this case, when we use a sampling distribution, that is going to be our probability distribution when we use random samples of size n. And so we have to be careful and we have to check, because if we're given the population standard deviation, we're going to use one formula in our normal calculator. If we are using a sample and have size n, then we're going to have to do something different before we put it into StatCrunch. So this is just a graphic look. It's a Venn diagram. The entire box, of course, is the population with the mean of mu, that's our population mean, and a standard deviation of sigma. So what we're going to do is we're going to be grabbing lots of random samples. We're pretty much only going to work with one at a time. But if you're doing a study, when you go get your graduate degree and you're doing studies, you're going to grab lots of samples. And so you can see here, there's 5 different samples. So each of those samples has a sample mean, which is X bar. We remember these from chapter 2, and then a sample standard deviation, which would be S. Now, if we keep throwing the samples back in, and so in other words, if they're drawn with replacement, then we would actually have infinite number of samples that we could draw. But we, like I said, we're going to work with one at a time. Okay, so on your resource sheet, you will see these formulas. What we're going to do is if we're dealing with a sample distribution, the mean would look like this. Okay, so it has the X bar to denote that we have a sample mean. We are going to make an assumption that that is equivalent to the population mean. Now, with the standard deviation, though, we have to adjust. And so we are going to have to, while we're working with the standard deviation for the sample distribution, we're going to take the population sample mean, or excuse me, the population standard deviation, and we're going to divide by the square root of n. And remember, n is our sample size. So if our sample size is 5, we're going to divide by the square root of 5. If our sample size is 1,000, we're going to divide by the square root of 1,000. And you'll see as we go through the problems. And so in StatCrunch, StatCrunch does not take care of this for us. And therefore, we are going to have to literally do this with our calculator. And that's why I believe your resource sheet has the word calculator next to it. Okay, so central limit theorem. We do not need to memorize this, but again, it's just that theorem that tells us that the larger the sample size, therefore the closer it gets to the population, the graph, our bell curve, is going to start to really look like a bell curve, where if our sample's small, it might not quite look like the bell curve that we want with the symmetry that we want. Okay, so these are all informational. We're going to get to the guts in just a minute, but a couple things we do need to know from this. And I'll start trying to work on some flashcards for these too. But if the random samples of size n, we want the sample size to be greater than or equal to 30. So if it's greater than or equal to 30, and they're drawn from the population, then the distribution would approximate a normal distribution. So you are going to get asked that in the homework. They're going to say, does this sample approximate the normal distribution? And you're going to have to check and make sure that n is greater than or equal to 30 in order for that approximation to happen. And then if we know the population mean, then we are going to say that that's the mean of the sample mean. And then for the standard deviation, we are going to have to adjust, just like we talked about. Okay, so this is just another informational slide to just kind of get you used to what we're talking about with the central limit theorem and with the population side and with normal curves. So with this first curve, look how crazy it is. And that's because it's just any distribution. Whereas if you come down here and n is greater than or equal to 30, then it starts to look like our bell curve, like we want it to be. And then on the other one, you've got your normal population distribution, which already has a nice bell curve. And then when you start to go look at your sample means, what I want you to see is that it's more narrow. And it is going to be more narrow because we're going to tighten up. By dividing by the square root of n, we're going to tighten up our standard deviation. It's going to be smaller, and I'll show you that as we get into the numbers. And therefore, our curve is going to be more narrow because always when we have a smaller standard deviation, we're going to have a more narrow curve. When the standard deviation is larger, like up here, then it's going to be, the data is going to be more dispersed and it's going to be wider. Okay, so let's see what they want here. So they did a study that analyzed the sleep habits of college students. So you can see we have the sleep time in hours on the number line, and then the data points are how many students have that sleep time. And so they tell me that the mean sleep time was 6.8 and the standard deviation is 1.4. Then at that point, we had random samples of 100 sleep times were drawn from the population, and the mean of each sample is determined. So they want you to find the mean and the standard deviation of that sampling distribution. So what we're going to do is we are going to, for the mean, we're going to take the mean that they gave me up above, and so that's going to be 6.8. We're not ever going to adjust the mean. For the standard deviation, though, because it's a sample distribution and because n is equal to 100, we have to actually adjust the standard deviation. So I'm going to take 1.4, which is what they gave me up here, and I'm going to divide by the square root of 100. When I do that, I get 0.14. So this is the standard deviation of the sampling distribution. So this is the problem worked out again. You can see my mean is at 6.8, and you can see on the number line that that's right about here. And then they adjusted the standard deviation just like we did on the other page. And look how narrow that makes it. That's because the new the standard deviation for the sampling distribution is very tiny. It's only 0.14. And so that is going to make the normal curve be more narrow. All right, let's take a look at this one. So assume the training heart rates of all 20-year-old athletes are normally distributed with a mean of 135 beats per minute and a standard deviation of 18 beats per minute. Random samples of size 4 are drawn from this population. Ooh, that's tiny, but we're gonna just play along because that's what they want us to do. Okay, so we can see that our mean is 135. That's right smack dab in the middle of our curve. And then they tell me that the standard deviation is 18. And so they went ahead and drew the graph for me. So what I need to know, the work's going to be on the next page, but I need to know the mean, the standard deviation, and the sample size. Okay, so the first question they're going to ask me is what is the mean of the sample means or the sample distribution? Well, we can just take the mean that was given to me in the problem. And so the mean is going to be the 135 that was given to us. But then they want the standard deviation of the sample distribution or the sample means. So on this one, we have to adjust. So we're going to take the 18 that was given to us. That's the population standard deviation, and we're going to divide by the square root of n. Remember, our sample size was 4. And so when we do that, we get 9 beats per minute. So with the population, we had 18, right? The sample, for the population, the standard deviation was 18, and therefore the graph was more spread out. This graph, you can see that it's more narrow than the one on the page before, and that's because now when we adjusted our standard deviation, we're now down to 9. And so our graph is going to be taller, and it's also going to be more narrow than the one before. Okay, that's it for part 1. Let me go do part 2.